In this lesson, we are going to be continuing with ionic compounds, chemical formulas, and naming. And we're going to be specifically looking at the last type of ionic compound, and that is the ones that are involving polyatomic ions. So first of all, polyatomic ions are groups of atoms that sometimes act together as if they were one single atom. So they're groups of atoms that sometimes act as if they were a single atom. Called a polyatomic ion. Most of them act like non-metallic ions, but not all of them. There are some of them that act as metals. If we just look over, here's a chart showing some common polyatomic ions. This is similar to what appears on the back of your periodic table. If you take your periodic table and flip it over, on the back is a list of common polyatomic ions. This is not all the polyatomic ions that exist, it's just some common ones that you'll most often encounter. So just minimize that. Coming back here, we've got a list. And the thing to realize is that, for example, if we look here, this positive charge, that's on the whole thing. It's on the N and the H. The N and the H are acting as though they're joined together into one atom. So this would be NH4 plus. We would visualize it as having the plus outside the brackets, showing that it's on the whole thing. And if we go back and look at our polyatomic ion chart, and we find ammonia or ammonium down here, NH4, so this is its name, so we would name it just as ammonium. CO3, flipping around. CO3, if we were going to visualize that charge of 2 negative is on the whole thing. Looking at our chart, we just need to look up the name for CO3, 2 negative. Here it is here, carbonate. So I'm going to write carbonate. You should pause the video now and try and visualize and name the remaining polyatomic ions. Okay, so you should have got ClO3 negative as chlorate, OH negative, this is a really common one we're going to see all the time, this is hydroxide, NO3 negative is nitrate, PO4 3 negative is phosphate, and SO4 2 negative is sulfate. We're going to look at how we can use these in formulas and names. The negatively charged groups combine with metals to form compounds. So for example, we can have the sodium here, this metal, combining with CO3 carbonate. You follow the same rules. So we're going to take this plus and drop it down to the carbonate, this 2 negative, and drop it down to the sodium. So this is going to become Na2. And we could write, just to visualize here, CO3 in a bracket because that 1 is on the whole thing. But then of course we don't need to keep this 1 as a subscript. It's not really needed, so this would just be Na2CO3. Ammonium is one that you're going to see that acts like a metal and has a combining capacity of +1. So for example, we could have ammonium, NH4 plus, combining with oxygen, O2 negative, and that would form if we, it's O2, here let me just, sorry that was a mistake, oxygen 2 negative. So this 2 will drop down here, the positive here. We're going to get NH4, and you have to put the whole thing in brackets. because the 2 applies to all of it, O. When you name something involving an polyatomic ion, you just keep the ion name. So this would be ammonium oxide. So let's write that down actually in another color because it's really important. So when you're naming, keep the ion name. So one more example of that would be if we had, put this in a different color again. So example, NaOH, common base that we're going to see quite a bit this year. This becomes sodium. And then we said back up here that OH was hydroxide. So we keep hydroxide as the name, sodium hydroxide. That's just a brief overview or introduction of how you write formulas and names using polyatomic ions. And we're going to continue that in class tomorrow.